James Webb made a startling discovery when it examined Uranus's moon Ariel, and the data it sent back to the lab blew everyone's mind. The thing is, Ariel was supposed to be a dead moon, at least as of right now, a frozen moon circling Uranus so far from the sun that almost nobody was paying attention. After Voyager 2 flew past it in 1986, scientists mostly moved on, took their blurry gray images, filed them away, and somewhat forgot about it. But when James Webb pointed its infrared eye at Ariel's surface, things began to look disturbing. The Webb telescope found a chemical signature that by any means should not have been there, and the more scientists looked at what Webb detected, the more alive the moon started to become. This video is about what Webb actually saw on Ariel's surface, why one specific molecule genuinely changes the whole scenario, and what it might mean for a hidden ocean buried under kilometers of ice. Because here's the thing most people get wrong. The terrifying part is not that Ariel has some exotic chemistry. The terrifying part is that the chemistry suggests something about Ariel may still be active right now as I talk about it, which in no way should be possible. I'm going to go through it piece by piece, and by the end, you will understand why a moon that nobody talked about for nearly 40 years just became one of the most important objects in the outer solar system. Let's start with what Webb actually discovered. Webb did not just take a picture of Ariel, but it actually scanned Ariel's surface like a barcode. Here's how that works. When sunlight hits Ariel, most of it bounces back into space, but certain wavelengths get absorbed by the chemicals sitting on the surface. Different molecules absorb different wavelengths. So if you split that reflected light apart and look for missing pieces, you can identify exactly what chemicals are sitting on the ground without landing, without even getting close. The Webb telescope just did that at Ariel, and what it found was truly astounding. On Ariel's trailing hemisphere, basically the side that faces backward along its orbit, Webb detected significant deposits of carbon dioxide. Researchers described some of the most carbon dioxide-rich deposits found anywhere in the solar system, possibly at least 10 millimeters thick in places. To be honest, that alone was surprising. But then Webb found something else entirely: carbon monoxide ice. And that is where the story gets genuinely strange. You see, carbon monoxide is fragile. Under Ariel's surface conditions, it should not stay stable for that many years. Scientists estimate that carbon monoxide is only truly stable at temperatures around 30 Kelvin. Ariel is warmer than that, which means if Webb is detecting carbon monoxide sitting on the surface right now, something has to be putting it there, continuously and more recently. A dead moon does not keep refreshing unstable chemicals on its surface. Something has to be supplying them. And that something is either coming from above, like radiation raining down from Uranus's magnetosphere, or it is coming from below, from inside Ariel itself. That is the open loop this discovery creates, and it does not close easily. Now, the radiation explanation sounds reasonable at first. Uranus has a magnetosphere, and charged particles trapped inside it can slam into surface ice and trigger chemical reactions. Those reactions can produce carbon dioxide and carbon monoxide from water ice mixed with carbon-rich material. Scientists call this radiolysis, and it is a real process that happens on other icy moons. But here's the problem with that explanation. Uranus's magnetosphere is not normal. Most planets have magnetic fields that align roughly with their rotation axis. Earth's magnetic north is close to its geographic north. Uranus does not work that way. Its magnetic field is tilted by about 59 degrees from its rotation axis, and it is also offset from the planet's center. The result is a magnetosphere that wobbles and tumbles in a way that is genuinely strange. Scientists are still working out how efficiently those charged particles actually interact with Ariel's surface. So radiolysis is possible, but it is not a clean, satisfying answer. The magnetosphere is too weird, and the carbon monoxide is too unstable, which means that something from inside is actually influencing it. And when you look at Ariel's surface, the interior explanation starts to look a lot more credible. Voyager 2 flew past Uranus in January 1986. It was moving fast, and it only captured about 35% of Ariel's surface clearly. But what it did capture was remarkable. Ariel is not a smooth, ancient cratered ball. It is torn open. Long gashes cut across the terrain. Deep canyons called grabens, fault-bounded valleys, slice through the surface. Some regions look smoothed over, as if material once flowed across them and refilled old craters. Some of those canyons have central grooves running down their middle, like a scar inside a scar. NASA describes Ariel as having the youngest looking surface among Uranus's larger moons. That means something was actively reshaping Ariel's surface more recently than the other moons. But the scars are not just old damage. A 2025 study looked specifically at those central grooves, the medial grooves running through Ariel's canyons, and found something unexpected. The shape and structure of those grooves resembles what geologists call spreading centers. On Earth, spreading centers are places where the seafloor pulls apart and new material rises from below, pushed up by processes happening deep inside the planet. Ariel is not Earth, but the geometry of those grooves suggests something similar may have happened in ice. The cracks may not just be damage, they may be pathways. Pathways for material to move from somewhere deep inside Ariel up to the surface. And if those pathways connect to deeper layers, then Ariel's surface may be a frozen record of something that is still moving underneath. And that brings us to the hidden ocean. Here's the thing about subsurface oceans that changes how you think about the solar system. They do not need sunlight. They do not need a star nearby. The heat that keeps them liquid comes from somewhere else entirely. Tidal stress, radioactive decay, leftover internal heat from when the moon first formed. These are not exotic energy sources. They are the same processes that keep Europa's ocean liquid under its ice shell, and Enceladus actively venting water vapor into space. Ocean worlds are no longer science fiction. They are everywhere we look. And now Ariel may be one of them. The 2025 study that I mentioned earlier also modeled the fractures on Ariel's surface and found that to explain their pattern, Ariel may once have had an ocean roughly 170 kilometers deep. That is enormous. Buried under ice? Yes, but enormous. The same study found that Ariel's orbit may have been much more stretched out in the past, more eccentric, which would have caused Uranus's gravity to flex and pull at the moon as it moved closer and farther away. Over long timescales, that tidal squeezing could have generated enough heat to melt the interior and create a subsurface ocean. Ariel may not have been warmed by the sun. It may have been warmed by gravity. And if that ocean existed, or still exists, then the chemistry Webb Telescope detected starts to make a different kind of sense. Water interacting with rock and carbon-rich material deep inside Ariel could produce exactly the compounds Webb found on the surface. Those materials could then migrate upward through cracks and grooves, slowly leaking out onto the frozen terrain above. That means Webb may have detected not just surface ice, but the chemical fingerprint of an ocean that never fully died. But that is important, and there is one more piece of evidence that makes this even harder to dismiss. Webb's data also showed possible signals of carbonate minerals on Ariel's surface. Carbonates are interesting because of how they form. On Earth, carbonate minerals typically form when carbon-rich fluids interact with rock in the presence of liquid water. They are a product of water-rock chemistry. You do not usually get them sitting casually on the surface of a frozen moon unless something created them through a process involving liquid water at some point. The researchers are careful. They say this needs confirmation. The carbonate signal is not definitive yet, but if it is confirmed, it changes the entire story. That is not just nothing. That's a huge deal. However, there is one more angle here that almost nobody is talking about, and it might be the most important one. By the way, if you are finding this video genuinely informative and compelling, subscribe and turn on notifications because I cover exactly this kind of story where the discoveries rewrite what we thought we knew about the universe. And there's a lot more coming, and you don't want to miss it. Voyager 2 only saw about 35% of Ariel's surface. That means roughly 65% of this moon is still poorly mapped. We are building theories about a possible ocean world from partial images taken in 1986, one set of Webb spectroscopy data, and a handful of modeling studies. The most important terrain on Ariel, the northern hemisphere, the unexplored regions, the areas near those medial grooves, we have never properly seen. Ariel is not just hiding an ocean beneath its ice. It is hiding most of its face from us. The 2025 study on those medial grooves specifically noted that those trench-like features may be the best places to search for carbon oxides and chemical clues from Ariel's interior. The grooves are potentially windows into what is happening underneath, and we do not have close-up images of most of them. Scientists need a Uranus orbiter, one that can repeatedly fly past Ariel, map those grooves in detail, measure the chemical distribution across the full surface, and check whether the carbon dioxide and carbon monoxide are concentrated near those spreading centers. That mission would answer questions that Webb cannot answer from billions of kilometers away. Until then, Ariel remains one of the strangest incomplete maps in the solar system. And here's why all of this matters beyond just one moon. For decades, the short list of ocean world candidates in the outer solar system was relatively short. Europa, Enceladus, Titan, maybe Ganymede, maybe Callisto. Uranus's moons were not on that list. They were the quiet ones. But Ariel changes that calculus. If a moon this far from the sun, this small, this poorly explored, can show things of interior chemistry and a possible ancient ocean, then ocean worlds may be dramatically more common than the shortlist suggests. Researchers at the Planetary Science Institute have even described the possibility of Ariel and Miranda, another Uranian moon, as potentially twin ocean worlds. The Uranus system may not be a quiet collection of icy rocks. It may be an entire hidden laboratory of ocean worlds sitting at the edge of the solar system, waiting for someone to look properly. That is the bigger picture Webb cracked open with one set of infrared readings. Every explanation scientists have put forward to explain what Webb found makes Ariel more active than it was supposed to be. Ariel is terrifying, not because we know what is under the ice. It is terrifying because the more we study it, the more alive it begins to look. And until we send a spacecraft back, Ariel is going to keep its most important secret buried under ice. Do you think Ariel has a liquid ocean right now? Or was it something that existed in the past and froze over? The debate is real. So let me know what you think down in the comments below. And if you want to keep going, the next video is right there. Watch, and I will see you inside it.